Hello viewers, in this video we will see the assignment 8 suggestions for digital electronic circuits. First question, how many numbers of flip-flops are required to store 16-bit binary number? A flip-flop can store only 1 bit, therefore for 16-bit we require 16 flip-flops. Option D, 16. Second question, so for the second question, a microprocessor makes use of shift registers to store data before providing them to ALU for calculation. Consider two registers in the figure. Both are 8-bit serial in, parallel out registers. Two 8-bit data are to be serially shifted into the register to perform addition between them. Also consider a clock cycle of 10 gigahertz. The ALU takes 4 clock cycles to perform addition once data is available at its input. Calculate the time required to load and perform addition of two 8-bit numbers. So 8-bit register, 8 shifts are required, 8 clock periods. Total time required is 8 plus 4, 4 for ALU, so 12 clock periods. 1 clock period is equal to 1 divided by 10 into 10, 10 into bracket 10 power 9, 10 into 10 power 9. It is equal to 1.2 nanoseconds. So this is given, 10 gigahertz is given. So option is 1.2 nanosecond B. Third one, a group of bits is serially shifted into a 6-bit parallel output shift register with an initial state. This is the initial state. After the 5th clock pulses, the register contains. So third one, so this is the initial state and we have to shift these bits. So after first clock cycle, this will be there. Second clock, after the second shift, this is the content. After the third shift, this is the content. Fourth shift, this is the content. After the fifth shift, this is the content. But this 0 will be the fifth, will be entered into the flip-flop. So answer is 010010. 010010. D. Fourth one, a 4-bit serial in parallel out shift register is used with a clock frequency of 4 MHz. Considering the initial value is 000, the time required to transmit the input to output is, so it's a very simple. So 4 shifts are required because this is serial in parallel out. So 1 clock period is nothing but 4 microseconds. 4, so 1 clock period is 1 divided by 4 into 10 power 6, which is equal to 1 microseconds. Option A. Fifth one, a shift register that shifts the 1-bit position to the right at each clock pulse is initialized with 00. After what clock pulse will initial pattern reappear at the output? So for this one, fifth one, so this is initial value. So what you have to consider is XOR output equal to 0, because these two are 0. 0 means output will be 0, and XNOR output will be for 0 it is 1. So this one is given as input 1. At the clock, first clock we will get 10000. So now for this register, 00 becomes 0, and again the same thing, 000 is there. So again XOR output and XNOR output will be 01, and this one will be taken as input. So therefore now it is 1 and 100 will be shifted right. So likewise we come, so in the 14th clock pulse we are getting repeated sequence. Initially it was 00, it is repeated after the 14th clock pulse, but that option is not there. So I'll choose randomly 13. 13. Okay. Now sixth one, this sixth one for this given diagram. So clock 2, it is for left, it is for, you see, clock control mode. So next, so mode control is logic 1 and clock 2 is for left shift. So problem is left shift. So clock shift. So then applying 1, applying 1 at mode control pin using clock 2, option C, option C, option C. Next one, seventh one, consider a 4-bit Johnson counter with an initial value of 4 zeros. The counting sequence of this counter is uh, it will be 0, 8, 12, 14, 15, and then it will be 7, 3, 1, 0. So that you can refer the video lecture or notes, lecture notes. So it will be option A. Seventh is option A. So I mentioned here, initially it will be 0, 0, then 1 bit will come, then 2 ones will come, then 3 ones will come, then all will become 1, and then again 0 will slowly enter, 0, then 2 zeros will come, then 3 zeros will come, then all will become 0, 0, 0, 0. So that is equivalent to 0, 8, 12, 14, 15, 7, 3, 1, 0. This is the end of the part 1. Thank you viewers. We will see the remaining in part 2.